Okay, this is now looking at the resolution of forces and vectors. So we've got a fair bit to do here. Right, what we have here is we have a mass hanging down and its force on it acting down is 20,000 newtons. And you're told that the wire is at this angle here 40 degrees. So if this is at 40 degrees here, then this will be at 40 degrees here. And you are pulling it in this direction with your force T, the tension in the rope. And the tension, of course, it can be replaced by two forces. So the tension is almost like the resultant. You can split that into vertical and horizontal components. The vertical component, this vertical component here, must be equal to the weight. So if you had to find out the length of this force here, you know it's going to be equal to T sine of 40 degrees. Okay, and that must equal the weight, which is 20,000 newtons. 20,000. So if you rearrange that, you'll get T equals 20,000 divided by sine of 40. And when you put that in your calculator, you get the answer of 26108 newtons is the size of the tension. So we'd probably say 26.1 kilonewtons. The tension, by the way, for question A is in this direction. So that is where the tension is pulling it this way. We're going to use this quite a lot, this 26.1 kilonewtons, in the next few questions. Right, determine the magnitude of the force F. So we've just worked out that the tension this way is 26.1 kilonewtons that way, and we know that the vertical component is supporting the weight of 20,000 newtons going this way, but the force that is pulling this way must be counteracted by the force pulling this way from the tension, and that of course is going to be T sine theta. Okay, so T sine theta must equal the force in this direction, so that this length here must equal this length here. Okay, because they're an equal and opposite. So we know that's 26.1, we know that's 40, so that's 26,100 multiplied by the sine of 40, and when I put that in my calculator, we should actually get the value here, which comes out at 16781 newtons is the force. I've used the full version of this 26,100, which is 26,108. So that's the value of F there. We know we've got a heavy mass here with a weight of 20,000 pulling down this way, and we know it's being held by the tension in the wire going this way. We know that this angle here is 40 degrees. Okay, so there we go, this angle here is 40 degrees. We therefore know that this angle here is 40 degrees. We're asked to calculate the magnitude of the acceleration in this direction. Okay, so that's 90 degrees, which means that this is 50 degrees. This is at 90 degrees here. So this angle here is 40 degrees too. That is 40 degrees. Now we need to find out the magnitude of this here to find out how big the force actually is. So the hypotenuse is 20,000 newtons. Okay, that's the resultant, and the resultant can be split into a vertical component and a horizontal component, and or two components at 90 degrees. So if I want to find out the value of this here, which is the accelerating force, I would need to do 20,000 sine of 40 degrees, because as you know, sine is opposite over hypotenuse, and this is definitely the opposite. Here is the hypotenuse here, and when I do that, I get my magnitude of the force, which is let's see, 20,000 times sine of 40 gives me the sine of the angle being 12,855 or 56 newtons, shall we say. That's the value of the force. Now we need to know what the mass is. Well, weight equals mass times gravity. Therefore, the mass will be equal to weight divided by gravity. So that's 20,000 divided by 9.81, and that will give me the mass as being 2,038 kilograms. 2,038 kilograms. That is the mass. Okay, here's our mass. Here's our force. So the acceleration, using Newton's second law, acceleration is force divided by mass. The force is 12,856 divided by 2,038, and when you put those numbers in the calculator, you get an answer of 6.3 meters per second squared, because it's acceleration. Right, and finally, what do we have here? Right, we have a box of weight W is pushed up a slope against the angle. So what we can imagine here is that we have a force of the weight pushing down here, and that can be separated into a component this way and a component this way. The W is always the longest. It's the resultant force, so it's always the longest. And this, of course, will have an effect of pushing it down the slope. So what is the value of this? Well, the value, of course, is it's the opposite side. So I need to do W sine theta will actually is the value of that force. Okay, and you're also told you've got friction as well to overcome. Now, because you're told the box moves at constant velocity, you know the forces must balance. They must equal each other. So the forces upwards must equal the forces downwards, and you've got two forces acting down the slope, which is the one created by the weight, which is W sine theta, and it's also the one caused by the friction. So you add those two together, and that is what it is. So it's this one here is what we're looking at. F equals W sine theta.